Okay, this is the second liquidated damage video, and just a minute. I have a little cup of tea, so hopefully this will improve my voice. And this time, instead of doing we'll do a couple of scenarios. It'll be very much like our simple example, but we'll put how many months. And if we can do this in 6 months, 8 months, 10 months, 20 months, okay? And the examples are ordering equipment, right? Paying overtime, I don't know, mobilizing workforce. There could be all sorts of different examples, and if we can, our costs per kW will be, if we do it in 6 months, maybe it'll have to be 1,300. Do it in 8,000, 1,200. In 10 months, 1,035, which is kind of the new thing. In 25 months, maybe you can get it down to 980. Okay, not much. Eventually, I don't know, you're just wasting money by delaying. The IDC cost could even go up, so it's really the first ones that are the big one, and then we can put our total cost, which is just, we'll use the same parameters. Maybe I'll put those over here, and I suppose this time we'll even need kind of a performance ratio. So let's put a PR of 80% or something. So how about 82? And the total cost is our megawatt cost, megawatts, times the cost per kilowatt times 1,000. Okay, big number. Control D, Control R, Alt H9, right? Alt H9, Alt H9, and I ran out of space. Okay, blah blah blah. All right, and then so that's how we're setting things up, and then we're going to do the same kind of thing. This time we'll put the okay, why don't we put the energy? Okay, and the energy is the gross yield reduced by, F4 times the performance ratio times the megawatts, and then let's multiply. We need to see how much differential energy there is in each time. So let's say that let's take the last case, 20 minus this case. So this is how much extra energy we get added versus 20 months. So if we build it faster, we get more energy. And then we get more energy here, a little more energy, and now we need to look at the trade-off and see how valuable that energy is. So let's take our last scenario where we did it down here, and we put it in 3 different places where we have different values of the energy. So we can now put value of energy, and I think I'm going to end up doing a revenue calculation this time, aren't I? Times, let's do it, of course, with the times the this one. Ah, come on. And I bet you some of people are going to give me this goddamn thumb down thing because they're going to say, oh, this is too simple. Maybe they're right, but I don't see many people really doing an analysis, Control R, where they really look at 1, 2, 3, 4 scenarios, where they really look at the value of the energy. This is to the off-taker, and this is the cost to the IPP. I'm sorry, this is the total cost to the IPP, and they all come up with these numbers. God knows where they come up with them, but you know, this is the type of analysis that really should be done. And what I'm trying to say is that you should spend a whole bunch of time understanding this in the future and today, and you don't see this changing. The value of energy today might be really high, and then it might change later on. And so this performance ratio, liquidated damage over here, might be different for different periods of time. Okay. So once we have the value to the off-taker, then we can get the net revenue, or the net value of the scenario. And we'll do the same thing. How about I'll take these ones, okay? I gotta get up and get started with the day. This is the value we receive minus the, I don't think we need an F4 on this, minus the cost. Is that okay? I think we can do that, yeah. And I'm going to press the F4 a few times. I don't think I was worried about the negative numbers. We just want to get the smallest negative number. So in this case, the smallest negative number is here. Oops, we like a really quick delivery. I mean, the largest number, rather. Largest number is here. And in this one, the largest number is here. And just a minute, let me change a couple of assumptions to make it a little more interesting. Okay, I just changed the cost of the project, shift control C. Why did that take me up there? But then, you know, this one, we put the minimum, and this is what I was struggling with. What's going on here? With my, what? Oh, maximum. Oh, the maximum. So I thought there was some problem with the, and then we compare this to the maximum, so we can go to home and conditional formatting and new rule, and on this one press F4 and put an equal, press the F4 twice, right? Good. And then format that as a this one. How about now? Okay. So we get different, depending on where we are, we get different scenarios. And if we could really make it for 800 by delaying it, oops, no, this would have to be a really low number, wouldn't it? This would have to be a really low number before it would make it worthwhile. Control Y to put it back. And then we can finally get the liquidated damage. For delay. Now this is, I'm going to stop here. I think you could make a similar kind of analysis, a very similar analysis for optimal heat rates. It would be tricky. Optimal availability penalties, which tend to be simply based on the reducing arbitrarily the capacity charge, all sorts of things. So depending where we are and depending what our avoided costs are, we could, the penalties, let's do this thing we did before. The penalties are the value of the energy. I hope this will work. So let's put the difference in value between one scenario and the other scenario divided by the difference in the months, and minus this one. Okay, so this is the liquidated in terms of USD per month of delay. Okay, that's how we'd get it. And I hope I can copy it and get the same number. And then, of course, this one, we should have kept it on the dollar sign here, shouldn't we have? And, oh, come on. Can't go up, of course. So we can copy this to the next one and the next one, and we get a higher liquidated damage that if we really want to encourage people in Legos to get it on quickly, and if we're willing to pay a lot more in the PPA to get this value, we'll be paying a higher PPA price. Then we also should have a higher liquidated damage if they do get delayed. Okay, so that's, I think, for right now. Where am I? Just a minute. This is our liquidated damage example. This is, I called our solar example. I haven't finished it for the rest of this. And the videos are a little boring and a little obvious, and they're repetitive, so I'm going to stop.